Okay, well, I want to thank you all for tuning in and hopping into this webinar. I'm just going to start a couple of poll questions as we sort of introduce, so feel free to work your way through some of these poll questions as I sort of give a welcome. So firstly, thank you so much for tuning in today for our Altair HyperMesh and how it fits in your workflow. My name's Drew Buchanan. I am a senior applications engineer with TrueInsight. If you are unaware of who TrueInsight is, we are a channel partner. So we work directly with Altair with selling solutions, providing training and support. And we are kind of based all across the country. Our main head office is in Salt Lake City. Myself personally, I'm based here in Philadelphia. With this big storm, we're kind of getting on the East Coast. My background, I have my bachelor's and master's in mechanical engineering. I spent 8 years in industry, working for Westinghouse, doing wind turbine design, and also working with nuclear energy. So I've been exposed to a lot of different tools and got to really utilize a HyperMesh with using Altair solvers, but also utilizing other solvers. I think that's one of the really cool things about Altair as a tool. And after I sort of left industry, I jumped into the reseller space about 7 years ago and sort of been in this space. Great, so I'm looking at the polls right here, some pretty interesting. So we have different backgrounds of people. So kind of good to hear. Some of you have some exposure to Altair, some of you do not. So Altair is a company, and really one of the great things about Altair is its vision is really to sort of transform decision making by leveraging convergence of simulation, HPC, and AI. And what that means, obviously, we're talking today about HyperMesh and HyperWorks, which is pre-processing, so a tool that's utilized for setting up CFD and FEA scenarios. But we have a lot of other tools. So we have our own solvers, specifically if you want to solve the meshing capabilities within the area. But we also have some tools that are kind of not necessarily kind of traditional sort of CAE, more like analytics or IoT. Point being is, if you have some type of need, reach out to us. We probably have a solution we can kind of help out with in terms of where things are at. So appreciate you guys sort of answering the poll. There's definitely some interesting sort of answers right here. So definitely wide background of where people are at with different tools and ANSYS, Nastran, CAD-based FEA, some Altair users, and some that aren't using any FEA. So pretty great, good to see. So those of you who are unfamiliar with Altair, maybe obviously you're jumping into this webinar, but maybe you haven't been exposed to Altair that much. We have been around since the 80s, came out of Michigan and sort of the automotive space and aerospace industry for sort of FEA, CFD-based applications. But since then, we've sort of branched out, and we have solutions for a lot of different areas. You kind of see some interesting areas here: financial services, using our analytics tools, and some other areas like industrial goods, some industrial design. More often than not, if you have some type of challenge, we can probably meet you where you're at in terms of solving things and whatnot. So, all right, great. As I was looking at the poll answers, let's kind of go over the agenda of what we're going to cover today. So largely everyone here, some of you have seen Altair tools, some of you have not. So we'll be talking about HyperWorks and HyperMesh. We'll be specifically looking at geometry creation and manipulation, and then looking at meshing and questions. Obviously, it's a short webinar. I can't get into everything, but definitely things that I've utilized in my past, with other solvers where I've used HyperMesh in industry, things that are really advantageous about our tools and our solutions. And we'll close it out with questions. Obviously, I have my colleague in the chat. He's going to be answering questions as I'm going through this webinar. So feel free to send questions in the chat. And at the end of this webinar, I'm happy to answer any questions you have. And if, obviously I'm always happy to jump on a call or an email if it's something that's a more sort of detailed question to your own application. So what exactly is HyperWorks or HyperMesh? Some of you probably have heard the term HyperMesh. HyperMesh is the legacy name. When you look at sort of high-end CAE solutions, there's capabilities where you can pre-process and post-process versus, I know some of you indicated you're using a CAD-based FEA. CAD-based FEA doesn't have those capabilities, meaning everything's meshed on the body. Whereas in HyperMesh or high-end CAE tools, you can actually pre-process, meaning that you can set up your mesh and then you can send it to a variety of different solvers. That's kind of the beauty of working within HyperMesh and HyperWorks. So in our case, we're going to be talking about meshing workflows today, how we set up a mesh for a potential FEA case or CFD case or even electromagnetic. And you'll probably hear me through the course of this conversation. I'm going to be referring to things as HyperWorks. HyperWorks is the full scale environment where you can utilize HyperMesh, as well as if you wanted to post-process, which would be HyperView and HyperGraph. But in the context of this presentation, I'm referring to HyperMesh tools that are integrated within HyperWorks. So some of you guys, I know some of you have used Altair. Everything that's within HyperMesh is within HyperWorks. So just kind of keep that in mind. Some other great things about HyperWorks, obviously it's a multifaceted tool in the fact that you can run your your post, run your solver. You can kind of do everything within the same environment, but it also integrates with different PDM or PLM systems. One of the things that's very unique about Altair is we work really well with external solvers, external tools. It's a very common workflow where we may have a customer who has to use a Dynasolver or another solver, and we can sort of pre-process that data, or vice versa. If you're coming from another solver and want to post-process our data, you can utilize our tools. So kind of keep those things in mind. So let's kind of talk about some common workflow things. Obviously, one of the things that's really powerful about HyperWorks is its meshing and sort of pre-processing capabilities. So many of our customers are dealing with very large systems, things that are difficult to mesh. And so there's a lot of different applications of where we can kind of look at the geometry tools. So the first thing is you can actually create geometry within our tools. So we have some customers who maybe work in 2D exclusively. We have some electrical engineers, RF engineers who are using our electromagnetic solvers, and they may not have a 3D CAD software because they might not have to utilize it all that often. And you can actually create 3D or 2D geometry within our tools, which is great. Also, other customers who are doing structural type scenarios and they just prefer setting our geometry tools up. The other application is we have many customers who are coming from their own CAD platforms, CATIA, SolidWorks, et cetera. And I'll show you all those. We can import and bring in those different geometry models within our case, assemblies, sub-assemblies, bodies, et cetera. We can bring those in. The other really cool thing about our pre-processing tools within HyperWorks is we can, obviously Altair has powerful solvers. We can solve these cases with our solvers, but like I already mentioned, you can pre-process our data. So say you want to utilize your current solver, you can actually sort of generate the mesh and sort of adjust your geometry and then send it out to your own solver. And lastly is just the amount of capabilities. I'm going to show you some really cool kind of workflow things in terms of geometry modifications and things that kind of make your life easier in HyperMesh. But you can really repair, adjust, or fix any type of geometry for any type of model within HyperWorks. So here's kind of the workflow here. Some of you legacy guys, this is the new working environment of where the geometry tools are stored. So the first option is within HyperWorks, we can interactively create or edit that geometry, meaning that we can create our own sketches. We can actually use some own kind of creation of solids directly within the tool. Or another very common workflow is we can import geometries from other CAD tools and defeature. This is such a common workflow. I know my own sort of experience where I might have something with a wind turbine within a PLM system with a lot of subsystems. I would have to go back, if I was not using HyperWorks, and go back to my designer and ask to make changes to pre-process that data. Within HyperWorks, we can do everything. So for instance, if I want to remove holes, if I want to remove logos, anything that's a geometry feature, I can sort of adjust or edit to repair. And these would be things that you typically wouldn't model in most structural analysis, like a logo. That's not really going to change the stress or displacement in your application. And it's better sort of to defeature those applications to kind of eliminate any sort of meshing problems later. So great. The other kind of really powerful thing, and kind of alluding to the example I just talked about, it was so common, you know, in my own sort of career where I'd be working on a model and it would be designed by somebody within my company that I didn't have any say in how it was designed, meaning that in terms of how they model it in CAD. And we know in CAE, if you have poor sort of geometry creation, that's going to influence how you're meshing or solving. Like you're not going to, if the geometry isn't created properly, you can potentially have errors when you're actually meshing the system. So one of the really kind of neat tools within HyperWorks is this sort of topology visualization. So what that means is when you sort of have geometry within HyperWorks, you can directly identify if edges or surfaces are knitted to one another. So pay attention to this. I'm going to come back to this slide as we kind of I jump into HyperWorks to show this. But a free edge means it's only connected to one surface. So say you see that red edge and you're actually supposed to be connected to two surfaces. That's a good indicator that you haven't properly stitched surfaces together. The green edge is going to show you that you have a proper sort of associated connection. Yellow would be non-manifold, which again is not something that's for a T connection. And then a blue edge would be suppressed. So these visualization tools really help in terms of understanding where you need to potentially fix or repair, you know, kind of bad geometry. All right, so let's jump into HyperWorks. So the first thing I want to sort of work our way through is geometry creation within the tool. The first thing you'll note is you have a nice banner right here. Again, you legacy guys, I sort of learned HyperMesh a number of years ago. The old panel orientation was what you would typically utilize. You can still utilize this here. So if you used HyperMesh a number of years ago and you want to use the panel view, you can. I'm generally working off the new GUIs. There's a couple commands I'll still use panels for, but the nice thing is most of the commands are sort of built into the new GUI environment within HyperWorks. The other thing I'll point out here, so I mentioned I wanted kind of to show this. So in terms of geometry models, you sort of see everything right here. All sort of the major sort of external CAD softwares are out there. The other thing is there's also generic CAD formats. So if you're working with an open source CAD tool or something that's not one of the major players, you could just export your CAD file as a Parasolid or STEP or STL file and bring directly into HyperWorks. Same thing with kind of exporting. So after you've actually set up your model, after you've meshed it, you can export this out to different solvers. Obviously, Altair, we have all the different solvers you would need for CFD, FEA. We have an implicit solver, an explicit solver, but again, it's just a workflow. Sometimes you run into certain customers need to use other solvers. You can prepare and mesh everything within HyperWorks and then export it out to these other solver tools out there, which is, again, pretty cool. All right, so let's kind of go through this. I'm gonna go through a pretty simple workflow. The first thing would be, you know, if you're someone who doesn't have a CAD platform and you want to sketch everything within HyperWorks, you can do that. So I specify my plane, which you just saw me do, and then I can just go through kind of geometry creation right here. You know, within the geometry creation, I can specify dimensions here. And like a lot of other CA tools out there, kind of you're tasked with kind of maintaining your dimensions. So just make sure you maintain your dimension orientation. I'm gonna say a 10 by 5 inch box here, which is great. Okay. And then I'll specify also just showing some other capabilities here. I'll just say there's a hole in the center of the system. And you'll also note that HyperWorks points out to you if something's fully constrained or under constrained. So again, nice CAD tools. You know, there's, you know, in terms of creating your geometry, you can do all that directly within the HyperWorks interface, which is great. So once I've kind of gone through this, I can actually create or sort of extrude my body. And in the entity selection tool here, I can go off of lines, but I've made surfaces. So I'm just going to click on a surface. And just through dragging with my mouse, I can I can specify and move this in and out. I'll just say 5 inches, and there you go. I've created a geometry just like that, which is pretty cool. It shows you how quick you can kind of create this geometry and kind of go through that actual geometry creation. And you can do that to kind of create whatever surface you want within a system. There's some other nice tools within the actual geometry creation. So specifically, I can use specific solid bodies, kind of preset like cylinder, box, spheres. And then you can use like booleans and subtractions to kind of create other sort of shapes, kind of like you would if you've ever done any type of 2D modeling. You have these capabilities within the Altair suite. All right, so see right there, pretty cool. I kind of created that cylinder and made that geometry. So it gives you an idea of creating that geometry. Now, a real common workflow is, if I exit out of this, I want to save, is I'm actually going to import a geometry. That's probably going to be a lot of the common workflows for a lot of you. You're bringing in a geometry from another CAD tool. And, let's sort of open up a file from another geometry sort of tool. So right here, you kind of see SolidWorks. And again, I just want to illustrate right here, all the different kind of CAD formats, CATIA V6, SolidWorks, Rhino, et cetera, as well as sort of the generic CAD formats. So I'm going to bring in this file right here. The kind of cool thing about this is I can specify my import options. I can sort of change my hierarchy when I'm kind of importing in. And the other real powerful thing about HyperWorks is sort of how it integrates with PLM systems. So you see the PDM attributes, metadata, et cetera. I'm going to keep everything as the default. All right, so I bring this geometry in. And so this is a workflow that I used to run into a lot. I kind of related again to kind of that application. I remember one of the wind turbines I was working on designing had, probably about 10,000 different sort of integrated parts. And we might be analyzing a subsystem. So I might not necessarily be involved with everything in terms, it's impossible to be involved with everything there. And so I would be left with 2 choices if I got a bad geometry coming in. I'd either have to go back to the CAD designer, spend time having them update the geometry in the model in the PLM system, or with HyperWorks, I can kind of make some of these changes directly. So things that I know that aren't going to change my system, meaning like in this case, we have a small logo right here. That's not going to change the stress. I want to sort of remove that logo. Maybe a fillet in some of these holes. I can kind of go about sort of making these changes. So let's kind of see some of these D-feature tools. So in geometry, you have your creation tools. I'm going to jump into actually editing within kind of the edge tools in a moment, but there's a little D-feature icon right here. And again, pay attention. Everything I'm doing so far is directly within the kind of the nice GUI and the icons right here, just by my mouse click and mouse controls. So first thing let's kind of eliminate this logo. I hit find, it's going to automatically highlight it. It pretty much grabs everything. Now, if it doesn't grab everything, like it's not grabbing the eyes here, I can sort of highlight and grab them. So I'm just going to click and make sure I grab every surface here. Okay, great. And just going to do this selection. So again, just mouse click, it's just a mouse selection. And I almost have everything now. And then hit remove. So I've removed that logo, and that's just a pretty cool feature. Another common thing I might see of sheet metal applications is cuts coming into the tool. Is actually kind of changing and removing cuts. But in this case, I want to remove this fillet now. So I'm going to go to a fillet, just click on it and hit remove all. All right, great. So you kind of see it. It's rather than having to go back to the actual CAD tool, I can make these changes on the geometry accordingly. Kind of last thing let's do, let's look at the holes. Hit find. Now in this case, I don't want to remove all the holes. One of the cool things is I can zone in. Rather than doing everything at once, I can do individual components. So I can just click on highlight in this face, see how I'm removing the hole. And there we go. And then once I'm done, I can sort of exit the tool. And you see right there, I kind of have my finished interface showing up. So definitely pretty neat in terms of sort of geometry modification and changes. All right, so let's open up another application here. I want to kind of show an example of a geometry of where I want to actually make some geometry changes. So this is an application I would run into a lot. And I'm sure a lot of you probably can relate to this. You know, maybe you're doing the geometry change, but inevitably you're working across teams and somebody else maybe made a design. And so you're tasked with, you know, hey, Drew, I want you to run a stress analysis on this part, and I need it on my desk as soon as possible. And I go inevitably to try and mesh it, and I run into errors. And a lot of it is due to geometry. So some of the great things about HyperWorks is it has these kind of built-in sort of tools that illustrate where you need to make changes in your geometry. So at first glance, this looks pretty good, right? It looks blue. I don't see any issues with it. But one of the tools I can do is I can highlight which edges are connected to the system just through a basic visualization command. So right here down at the bottom are all your visualization commands within HyperWorks. If I click on this face color component, uncheck automatic, and what I can click on is topology, is it turns all these colors to red and green. Now remember from my slide right here, red means should only be connected to one surface, and green means it's connected to two surfaces. So when I kind of zone in right here, you guys can see there's definitely some issues right here. So first thing, obviously there's this crazy little sliver here, which is not something I'd want to mesh. It's also not connected to the surface. There is also, if I zone out here, see how that's face? This is not right because it's not stitched properly. So if I look at those surfaces, it should be green. So definitely I can sort of easily see where I need to make some changes in my system. So let's actually kind of go through how we would do that. So in this case, I can actually make all the changes directly to the geometry right within HyperWorks. The first thing I want to do is I want to get rid of this weird, crazy sliver. So I can go to split and hit line. And what this is doing is it's splitting the surface, because when it got imported into HyperWorks, it came all as one surface. So when I click on the surface right here, you see how it's highlighted? And then I can split by the line. So I'm going to hit specified on the tool and click on that line and then hit split. All right. So once I do that, you actually see that it kind of creates this green edge. And if I change my selection tool here, instead of clicking on the entire part to surfaces, so right here, just change it right there by the surface, you see how now it highlights there. All I need to do is just hit delete on my keyboard and hit delete. And I've gotten rid of that weird, nasty piece. Now, wait, hold up. Now it's showing as red. Well, the reason it's showing as red is because this top surface isn't stitched to this surface now. So like if you're familiar in kind of CAD commands, like knitting surfaces together, that would be stitching a surface. So if I click on stitch, all I have to do is just click on that edge and HyperWorks does it for me. That's kind of the great thing. HyperWorks HyperMesh has been around for 3 decades. It's kind of built this technology to make your life really, really easy in terms of pre-processing. The other kind of cool thing about this, another visualization command is I can kind of isolate everything that only has a free edge. Okay, so I'm seeing it right here. But say you're working in like kind of a system where it's kind of hard to see things. I can also change my visualization to be like completely wireframe. And then I see everything that's red is bad. So great. Let's kind of show a way of cleaning up. I'm not going to clean up everything, but I do want to show some useful things. So the next thing I want to point out is we patched by an edge. We use that split tool. So we're splitting the surface and then sort of deleting the edge. What happens in the case where I want to maintain the edge? So in this case, this edge is not sort of connecting. I can actually click on the surface tool right here and select patch. So all I have to do is click on the line and then just drag, move that surface down. And once I do that, it does it automatically. It patches that surface. See how it turned green? So it just, by using kind of that proprietary sort of pre-processing technology, is able to kind of clean up that surface for me. So another kind of cool thing I do is I can actually extend the surface. So here's another issue in the model right here where there's an opening right here. And all I have to do is just click on the edge and drag it until it kind of snaps directly and it turns green. So definitely some really cool things. This is something that I banged my head across my desk with. It's something that it's definitely, I'm sure a lot of you can relate to some of the challenges, but this kind of makes your life easier in terms of geometry prep and kind of cleaning up your geometry. So there's a couple other things I could clean up, but I'm not, just for the sake of time, I'm not going to clean it up, but you guys can understand you have some of this nice geometry creation and ability. So from a workflow perspective, that's the first thing I'm going to do is I'm going to utilize the power of HyperWorks to kind of clean up my geometry for my systems. I'm going to come back to my PowerPoint here. And so we talked about geometry creation, and then geometry creation and manipulation. The next thing we can talk about is meshing. So once you have a pretty good geometry, you use those topology visualization tools, everything's knitted to one another, proper stitching of edges, you can go to meshing. Now the meshing within HyperWorks is great because you can really mesh. Technically you can mesh for 0D, I'll explain what that is, but 1D, 2D, and 3D applications. Multiple different types of elements, so bricks, quads, tris. Some of you I know in the polls are currently using FEA-based CA tools. They're limited because they only have certain elements. You're going to have all the different types of elements and flexibility directly within HyperWorks. The other thing that's really cool about this is obviously we can use our own solvers, but the thing that's really cool about HyperWorks, I know some of you are using some other solvers out there, is you can still utilize those solvers if you want, and we can prepare the mesh entirely within HyperWorks. Something that I can relate to, I've used other CA tools. The meshing capabilities are definitely much limited in terms of what they can do. And these cases can be set up for a variety of cases. So FEA, CFD applications, and electromagnetic applications. You can set up for various types of studies. You're not just limited by a straight structural study. You can set up everything. The other kind of cool thing about it is you can automate this process. There's a lot of automation built to the Altair suite. So as far as the parameter criteria files, I'm going to get into what those are, but that would be where you can, a real common workflow. A lot of you guys probably work with a lot of the same type of products. You may be pushing out different products, but you kind of know over time, working as an engineer, so you guys have come into it, you can kind of encounter what you need to have for a good mesh. And you can actually automate these parameter files, which specify your meshing processes. And the last thing, there'll be certain applications, and I'll show this, where you actually have to manually control the mesh. So that would mean maybe I want to go to a specific edge and sort of adjust densities. Maybe I want to sort of remove an individual element, or maybe adjust a node. The kind of cool thing about this, and I'll show it, is you can really, anywhere in a model that you've meshed, you can sort of adjust. Other tools, you can't necessarily do that. You can't necessarily delete one element and kind of recreate an element. You have to go back and remesh the entire system or change the geometry. You don't have to do that within HyperWorks. And that, again, can be really game changing in terms of time savings for you all. Some of the meshing tools, obviously we have mesh controls. I think a lot of you are familiar with what mesh controls are, but that would be specifying around an individual feature, what that mesh density is going to be. In general, most applications that a lot of you are going to be running in meshing is you're probably going to automate most of your jobs. You're probably going to inevitably run into some type of case where it's just a pain in the butt, and that's where you can utilize our tools to manually adjust. But also the automation features we have kind of save time versus other tools. 1D meshing, 2D meshing, 3D meshing. So 1D meshing would be like rigid or bar elements. 2D meshing, probably a lot of you are very familiar. We'll be looking at a 2D meshing case. And 3D meshing, typically you're going to create the 2D mesh first, and then sort of extrapolate across the layers for TET and hex meshing, et cetera, for 3D meshing. So here's the meshing ribbon. Everything's organized very in a very nice manner. So you kind of can see where everything's sort of organized. So the controls here, this is going to be your actual individual settings in terms of parameters and criteria and mesh controls. These kind of I use all the time for automation. There's a nice tool within HyperWorks called a batch mesher, which kind of automates the meshing and sort of reads directly in your parameter files. And I'll show a case of how you can utilize that. 1D meshing would be kind of traditional line-based elements. So beam sections, whatnot. And then surface meshing, you kind of have a lot of different surface 2D meshes available to you. And lastly, our 3D mesh. So everything's kind of sorted, organized on this tree. But here's some of the other kind of advanced features that a lot of other tools out there do not have these capabilities. So on the Elements tab right here, so you kind of see this 0D. That would mean if you're trying to adjust a node to have a specific mass or specific spring, this actually is in a lot of solvers you can't do. So this is something I use all the time where I can control an individual node with an individual mass or spring. It's definitely game changing. It's something I use a lot. The other thing is the element sort of editing tool, meaning and I'll show this as we kind of work our way through a demonstration where I can actually adjust an individual element, a group of elements. You kind of see a refinement there. And this is, again, things that are not typically available in other tools out there because, you know, it's a very difficult thing to do. And Altair has done a great job of sort of integrating it. I mean, it's kind of, you know, where it started, you know, decades ago in terms of pre-processing technology. So we'll kind of take a look at, there's definitely a lot of really cool things you can do. So let's jump into a demonstration now. Let's jump in. I'm going to close this file. And I'm going to open. And we're first going to talk about automatic meshing. So the first thing you'll note, it looks pretty similar. Obviously, it's a 2D representation of the last model, but the first thing you'll notice in topology, this does make sense because yes, red edges aren't necessarily a bad thing. They just mean they're only connected to one surface. In the 3D context, they were bad because, you know, they weren't connecting all the surfaces, but everything has been cleaned up here for us. So I'm going to turn this off, just kind of make it a little bit easier to view some things here. So I'm at my automatic mesh. So that's kind of the first workflow. Check our geometry. We talked about that. And now we can actually jump into meshing. So if I go to my mesh tab right here, the first thing we can do is we can go to our, since this is a 2D mesh, we're going to use the 2D mesher. Mid-meshing, there's a whole bunch of mid-meshing, which is very capable for sheet metal. It's definitely something, you know, we could spend a whole webinar talking about. But in this case, we're just going to use kind of the batch mesher and the manual mesher. So the batch mesher is a great automated meshing tool. So we're going to switch to the batch mesher, and it's something I use a lot where it kind of automates the entire meshing process. One of the things that the batch mesher looks for is it looks for the actual parameter or criteria files. So let's kind of go over what these things are. So I'm first going to open up the parameter file. So you kind of see right here, this parameter file, this controls everything that you want for a mesh. And this is what I was saying, that as you guys kind of work through your own systems, you're kind of going to know what's going to be the kind of the best setup for your own case. I can control my element size, the type of element I want to utilize, the element order, and I can go through all of these and specify my specific sort of mesh density feature densities I want to sort of utilize. The great thing about this is I can also save this as a file. So as you know, I've run into a lot of customers that use this and they have specific parameter files for specific BOMs or specific components they're utilizing. I've created one just for this webinar. I'm going to open it up. And you're going to see once I open this up, it kind of changes some settings right here. And it kind of, I'll step through a couple of these options. But the other really cool thing about this is, you note, I can still edit these. I'm not locked. So in this case, I'm going to change my element size to be 2.5. And then we can kind of go through some of these other features. So maybe I come down to my hole density. I can change it to be automatic, which means the solver is going to sort of specify our washer sort of dimensioning in terms of elements. I can also go down to my like node quality, meaning how nodes are arranged. So you see right here, if the meshing automatically sort of can sort of adjust to make things more uniform, you can do that. So I'm just going to sort of make some of these changes. That's the other kind of cool thing about this new GUI. Some of you legacy HyperMesh guys, they didn't have some of these features there to sort of explain what these features are. Obviously, it was always in the user manual, but it kind of makes things a lot nicer from a usability perspective. Great. So I'm going to hit apply. And remember that everything I'm keying in here is just my settings. So once I do this once, I don't have to go through and change these. I'm just kind of illustrating that you can kind of change these settings for you to kind of see right here, my fillet settings, et cetera. You can set these, and this is kind of what I was talking about in terms of automation for your systems. The next thing I always like to do is create a criteria file. So across all of FEA, we all know that it's a numerical method, and there's certain things we need to look for when we're evaluating a mesh. And that's, like one thing would be an aspect ratio. Aspect ratio would be when you look at an individual element, when you look at an element's largest side by its smallest side, you don't want to have too large of a ratio. So especially for structural analysis and warpage and whatnot. Same thing to the parameter file. You can sort of save these criteria files. I have created one, and this I think will become a little bit clearer in a moment. This is really like after you mesh, it kind of tells you if you've have any failed elements that you need to address. So I'm going to open up my criteria file here, and I'm going to change my target element size to be 2.5. And you see, as soon as you change something that's not within your criteria right here, so you see how my minimum size is set at 3. Well, I'm shooting for my target element size to be 2.5, so I need to adjust that. I'm gonna change that to 2, and I'm gonna drop this down to 5. So I want to try, if it's too large, like it's at 9, it's not going to kind of get to that range. So now I get rid of those red warning symbols, hit apply, and great. Now I've set my settings, and all I have to do is highlight my surfaces here, and you see how it's grayed out with the mesh. That's taken care of by the automation within the parameters option. If I hit mesh, you kind of see right here down at the bottom, and everything I'm running, just so you're aware, I'm just working off a standard 4-core laptop. So, that's kind of the other beauty about HyperMesh, HyperWorks, is it can really kind of mesh and kind of go through this meshing creation very easily. All right, so I'm looking at my mesh. One of the other really cool things from a visualization perspective, we talked about topology, but I can also look at element quality. So I turn on this element quality value right here, and I can sort of see directly how my system. So this is exactly what that criteria file is. This is based off the settings I'm specifying. So I already mentioned aspect ratio. Aspect ratio, generally in most FEA, obviously it's a rule you try to live by. You try to shoot for things less than 5 or at least less than 10. There'll be cases where some elements might be above that, but it's a good ballpark to know if you have a pretty good mesh for getting reasonable stress and displacement results. So if I sort of adjust the slider, you see how it shows the entire thing, and I have a really good aspect ratio on the system, but it will point out to me where I have sort of larger aspect ratios or elements that might be a little bit poorer quality. Same thing, another good thing I look for is warpage. If I have any sort of, again, warped elements, it's going to show me, and nothing's meeting that value. So pretty cool thing in terms of looking at sort of my method. And that's kind of the purpose of this parameter file. It automates this process for you. So inevitably, though, you're probably going to run into cases where you'll try using the batch mesher, and you may have to some things might fail, and you might have to do a manual mesh. So if we go to our actual manual mesh, I'm going to show you a way of how you manual mesh here. All right, so I'm going to open up my file right here. So again, relating this back to our workflow, good geometry, try to take advantage of automation with the parameter criteria files. But then we'll talk about how to actually go through some ways you can sort of adjust via a manual meshing method. Again, a pretty simple example, but it's going to at least show you some ways of how you would do this. Okay, so I'm going to change it off the batch mesher to a general 2D mesh. And you see right here, we have our actual sort of bracket right here. So again, I have my topology tools here. Everything looks good. So again, the first thing I check, nothing seems out of place. These green edges make sense because they're sharing across the faces, so that's great. So if a manual mesher, I'm not typically going to be utilizing a parameter file. Technically you can, but that's generally used for a kind of batch mesher. So I highlight it right here, and I can actually manually set the element size. You can actually specify the types of elements too. So I can specify if I only want to use quads or tris for a surface mesh. I'm going to go with a quad and then hit mesh. So the cool thing about this is once it creates the mesh is I have a lot of kind of unique controls in terms of how I can sort of make changes. So the first thing I always like to do is I kind of zoom in and you'll see all these numbers labeled across. This is telling you like element density. So I can actually click on the density icon right here and dynamically highlight the edge right here and manually just change it. So I can specify 12 and it's automatically going to adjust this edge. And you see how it grows outward, it's going to adjust, which is great. I can go to this edge here and specify 12. And I've sort of made those changes. And again, this yellow is not a bad thing. It's just saying, hey, these are smaller than 2, and that's fine. This is a pretty good system. I can click on my aspect ratio. I don't have poor aspect ratio. I don't have bad warpage. I mean, at this point, I'd probably be ready to run a system, set my boundary conditions, but I just want to show you guys some more sort of tools you can utilize. So one of the cool things we know is you can also adjust geometry. So one of the things is you sort of see how density is adjusted by going off of edge. We can kind of create some new edges or split surfaces, directly. So I've already created the mesh. I can click on the geometry tab and I can specify splitting this surface. And I'm going to use the interactive tool, which just allows me to drag and drop. And you see when I do that, it interactively automatically creates that split for me, and then also it adjusts the mesh density automatically for me. This again is a common workflow I'll do. If I start seeing like problem areas, I might split some faces so I can sort of distribute my element density a little bit better. So that's something that's very useful I'll typically do. And just kind of showing you right here. And now what I can actually do is now that I've kind of made the changes in the geometry, if I want to remesh it, I can go back to my mesher right here. And I can click on general 2D mesh and I can just click on that individual surface. So maybe I want to go a little bit smaller to be at 2. And you see, remember, because these edges outside of here are controlled by a 2.5 density, this 8 and the 4 are kind of locked in place, but it adjusts the mesh density up here. So kind of shows you can kind of really sort of adjust accordingly. The other really cool thing I mentioned is we've been talking about meshing and geometry, but I can actually look at individual elements and make changes within elements. So if I go to elements right here, the first thing I'll do is I'll call on edit elements. And one of the most common workflows I'll do with really kind of bad geometry is I can sort of adjust the node. I can click on a node and sort of drag and drop. And you note by my criteria right here, so let me change my criteria to be maybe minimum size. And then hit the move icon, I can sort of adjust here and you can kind of see how it changes my graph and I can move these nodes easily. This is something most other CA tools can't do, or they can't do it very easily. This is something that really shows, really something that's really, really powerful about HyperMesh. The other thing I'll typically do is if I have some bad elements, maybe I'll split them apart. So you see how it's kind of splitting these into 2. I can also replace elements. So maybe I have some bad elements or some areas where I just want to replace, I can replace them. I can also adjust the density on individual edges. So the purpose of this is rather than having to bring up the whole meshing interface, I can click on an individual edge and make that change. So let's just maybe go to 7 here and it's going to adjust. And it kind of cleaned up a lot of those sort of areas right here. And this is not a bad thing. It's just saying I'm increasing the number of elements in my system, which is, it's not, if you're seeing red here, this means, oh, I'm adding more elements. This would be a system that would typically solve very quickly, but it's just one of my default criteria values. So again, if I change the criteria to minimum size, everything kind of looks good, or aspect ratio, there's nothing that's bad here. So, I mean, that's why it's showing as red. But you kind of get the idea. You have some pretty powerful tools in terms of element creation. There's also some other tools I'm not talking about, like smoothing. Like if you had a really sort of jagged edge or something you wanted to smooth over, you could. There's also a create tool. So if I hit create, I can actually, kind of create my own sort of tool here. So let me hit create and kind of make some creations of tools and different elements. This would be if I had a gap. I haven't deleted any elements, so it's not really kind of showing here. But if I deleted the elements, you could have that ability to sort of adjust. Okay, great. So let me jump back into my my slide deck here. And there we go. So kind of reading workflow, set up your geometry, make sure you have a good geometry, and then go through the quality tools within HyperWorks HyperMesh. And obviously this is just the tip of the iceberg. I couldn't show you every single feature, but these are common things I'll do is I'll check my quality and then manipulate elements accordingly. One of the last things I'll do from a workflow perspective is morphing. Again, this is something that is super powerful and other CA tools don't really have these capabilities. So morphing really allows you to manipulate, after you've created a mesh, to sort of extrude a mesh outwards. A lot of other tools, they require you, if you want to sort of extrude a surface, maybe you run a structural case and determine that, hey, I want to adjust my thickness. You have to go back and readjust the geometry and then remesh it and then resolve. The beauty of HyperWorks is you can just morph that mesh, meaning you can extrude it outward, you can change an angle or an orientation and rerun. So again, it just saves you time from setup perspectives, which is what you want from a good pre-processor. The good thing about HyperWorks morphing tools, you don't have to do anything different. Once you mesh it, you can utilize any of the morphing tools. The morphing tools also are going to try and maintain your mesh quality and shape. So it's not going to just kind of distort your systems unless you are applying really crazy morphing. It's going to do a good job of maintaining that quality. So you kind of see in this picture right here, this would be a perfect application, everything highlighted in yellow. I want to extrude this surface out. Let's just say you ran a natural, like a structural case. This thickness is too weak. I'm seeing a pretty high stress. So best thing we can do is we know we can sort of machine it or make it to be a little bit thicker. So I'm going to go and sort of use the morphing tool to move this surface outward. I don't have to go back and remesh it or create a new geometry. I can just use morphing. And lastly, generally, like I said, you can maintain these features. So there's 3 different types of morphing tools available. Free would be very similar to what you saw in terms of how I was dragging a node with the element tool, except you can move it out of plane. With the element drag tool I just showed you, you're doing it in plane, like moving that node. With the free morphing tool, you can move it, out of plane or, in a different direction. Proximity, it grabs everything around sort of a set distance and kind of moves everything out. I'm going to show you an example of proximity. This is typically what you'll typically do for like a surface when you're trying to extrude a surface up and just move a mesh up. And then a volume, which is another real common workflow, is I can specify within this kind of translucent box that you're seeing, everything within that box you can manipulate and move accordingly. All right, so let's jump into a application of this. I'll close this down. And let's open up a morphing example. So again, this is a real common workflow, things that really help my life when I'm meshing. So I'm going to go into morphing right here. Let's first talk about proximity morphing. So generally when you're going to be using morphing is when you've already spent a lot of time meshing. Like it's generally for cases with large assemblies. And you don't want to have to go back and remesh everything, but you've already run a structural case and you determine, all right, maybe I'm not meeting some objective or I need to iterate. It would be where you go back and redesign. But the beauty of morphing is I can sort of I don't have to really change all my meshing. I can sort of adjust those problem areas. So in this case, I want to sort of extrude sort of a thickness of this hook. So I'm going to go to my views right here. And here again, it's another pretty cool feature. I can save views. So I have a view I've saved right on here. And I want to extrude this top surface up using morphing. So I'm going to go to my morph dialog right here. I'm going to specify proximity morph. And I'm going to change, again, the selection tools, by mouse click, I can change them. I'm going to specify this like freehand select tool just so you guys can see it. And all I want to do is I want to grab the top nodes. So rather than like manually clicking through all of them, I can just do a sort of a quick mouse selection. So I highlight them all and I grab all of them at once. And then the morph tool kind of snaps in and recognizes, hey, do you want to move this? What direction do you want to move it? And I want to move it in the positive Z direction. So I'm moving it right now. See how it's maintaining the mesh quality? I didn't have to go back and remesh it. I didn't have to create the geometry. So I'm going to go up to 1.5 and everything's maintained. So this is kind of the power of this tool. I use this. It's something that I know a lot of you guys have run into this before, where you run a case and it's going to save you time. Also relating back to PLM, PDM, and getting the designer involved. You guys can really iterate and solve these CAE cases much more efficiently than other tools out there. All right, so that's a proximity tool. The free tool is what it's going to do is, this is a large system, so I'm not going to use it here, but I could grab a node and you can move it with respect to a plane. I do want to show the volume tool. So let me open that. So again, here's another application. And let me open HyperWorks up. I think I may grab the wrong file. So it's just another application of using volume morphing. And I can sort of adjust. So as that opens up, so you kind of solve proximity morphing. You're actually grabbing a whole system of nodes and sort of dragging it upwards. And we're going to see in volume morphing right now. So let me grab the right file right here. Okay. So a body panel for a car. This is something, you might have a lot of different panels. It's not uncommon when I talk to different customers, working with automotive, that they may have spent months or weeks kind of refining their systems down, and with other sort of meshing tools. Here, it can be done very quickly in just a matter of mouse click. So I can click on morph and say like in like the mid panel right here, I want to adjust the volume. So I'm going to click on volume. And I'm going to specify maybe just right here in the center. And what it's going to do, it kind of creates that enclosure for me, which is great. That's what I want. I want to have that. So you see everything within this box, I can now manipulate everything within the volume. The other cool thing about it is I can split it up. So maybe I want to have a couple different planes that I want to manipulate. And then I can actually click on the move tool. So when I click on the move tool, you can see I'm just clicking right here on this edge that's yellow. See, when I do that, it kind of moves the entire volume in and out. I can click on, another location if I want. If I want to go right here, I can actually go to an angle and I can change that. These are things that would be so very difficult to do. Even with this general surface creation, something that would take time for your mechanical designer, and you guys can do it just through just morphing, which is really, really cool. So kind of the last kind of thing in your workflow, utilize morphing. That's really going to help you guys out in terms of sort of helping your workflow and pre-processing. So that kind of brings us to the end. There's a couple final things I did want to bring up. I encourage you guys, if you can, to check out I'm going to bring over my browser here so you can see it. So check out our website. We are going to be running future webinars on all bunch of different Altair tools and solutions. Our next one, I believe, is going to be on SimLab. But if you go to our resources tab right here, you can click on our blog. And this is something where it's not just HyperWorks. You kind of see there's a motion simulation. It's something that myself and everyone here at TrueInsight, adding new blogs, different how-to guides, etc., where you can go. The other thing I want to point out is our actual YouTube page. So just go to YouTube, search TrueInsight. If you feel like subscribing, great. You just search TrueInsight, no spaces, and that's going to bring you here. And just a day ago, we had a video out on Inspire Studio, which actually is a CAD-specific tool within Altair. We looked at geometry creation within HyperWorks, but you can actually do some pretty cool CAD features there, and kind of see FICO and a bunch of our other tools. So just take a look out on our actual YouTube page. And lastly, I just want to take the time to thank you all for tuning in. Really appreciate it. I know it's a short webinar, so I'll kind of take the time now to answer any of your questions. But if you have further questions, feel free to let me know. I'm going to paste my email in the chat, and I'm happy to sort of answer those questions. But firstly, I just want to thank you all for kind of attending. So I'm going to